Welcome to the Bodhi Unified Flow channel. I am Dr. Mari Muthu. Today, we are examining a critical methodology for construction management. Traditional construction projects often rely on top-down critical path method schedules. These master schedules are frequently built in isolation by managers, detached from the daily realities of the workplace. When these rigid plans encounter field friction, like late deliveries or missing information, they break down. The Lean Builder methodology counters this with a field-tested approach centered on the trades themselves. To implement this system, we first train the eye to identify and systematically remove the 8 deadly wastes that drain time and capital on the job site. Second, we replace long weekly subcontractor meetings with high-efficiency daily huddles, driven by strict visual communication protocols. Third, we install the Last Planner system, a 5-part framework that secures reliable scheduling commitments directly from the trades executing the work. Schedule reliability is achieved only by empowering the field leaders closest to the work to plan the work. Lean construction requires a specific lens for viewing site operations. Before a team can optimize a schedule, they must first learn to identify non-value-added activities. In construction, any task that does not add value to the final product adds time and cost to the project. The Lean framework categorizes these inefficiencies into the 8 deadly wastes. These wastes are tracked using the acronym DOWNTIME. The cycle begins with D for defects, materials that are damaged or incorrectly fabricated, forcing rework. This is compounded by O for overproduction, building components too soon or stockpiling parts before the site is ready for them. When defects or overproduction disrupt the workflow, they trigger the next 2 wastes. W is for waiting. Trades sit idle in anticipation of delayed materials, equipment, or pending information. This leads to N, non-utilized talent. When skilled craftspeople spend their time managing bottlenecks instead of their trade, their value to the project is lost. Next is T for transportation, the unnecessary movement of equipment or materials across the site. This occurs frequently due to I, inventory waste. Storing excessive materials on floors or in laydown yards clutters the physical workspace and increases the risk of damage. The final 2 are M for motion, unnecessary physical movement by craftsmen, such as walking excessive distances to access site facilities, and E for excess processing, meaning any redundant paperwork or over-engineering that adds no functional value to the build. Seeing the waste is the prerequisite for deploying any advanced Lean protocols. Teams must be trained to recognize these 8 categories to keep them from being accepted as just part of the job. Once the team can identify waste, the site must move to active field coordination. Traditional weekly subcontractor meetings lack the immediate day-to-day accountability required for complex builds. This illustration shows a team engaging in the daily huddle. This meeting operates under strict parameters. It lasts a maximum of 15 minutes, every participant remains standing to maintain focus, and mobile phone usage is prohibited. During this window, every trade leader, or last planner, must publicly answer a standardized set of questions while referencing the visual grid on the wall. First, what exact task are you working on today? Second, in what physical location? Third, how many workers are currently on your crew? The final 2 questions address immediate logistical friction. What are your current constraints preventing work? And what material deliveries are arriving today or tomorrow? To keep the huddle within 15 minutes, the team utilizes a moderation mechanism called the 2-minute rule, also known as ELMO. Enough? Let's move on. If a specific constraint requires deep problem solving, any team member can call ELMO. This stops the conversation, pushing the detailed discussion to a post-huddle breakout so the time of the other foreman is preserved. By requiring public, daily answers to these questions, the huddle turns trade partners into active, accountable planners who coordinate directly with one another. Daily coordination requires immediate data. Retaining schedules on private spreadsheets creates information silos. This data must be translated into public, visual artifacts inside the job trailer. The most crucial of these is the constraint board. This is a physical matrix designed to track logistical roadblocks out in the open. It features 4 mandatory columns: what, where, who, and when. The what and where columns document the precise nature of the roadblock, such as a missing inspection, and its specific physical location on the job site. This removes ambiguity about what is actually stopping the work. The who and when columns establish the commitment. A specific champion is assigned to remove the roadblock, and a publicly visible deadline is locked in. Visual management removes ambiguity. By recording in-streams, champions, and deadlines in a public workspace, the project team creates a transparent record of responsibility. The core engine of this methodology is the last planner system. It operates on a central principle: planning authority must rest with the trade foremen who physically execute the work. The last planner system requires a sequential execution of all 5 stages to be effective. As shown on this board, the steps cascade from long-term goals to daily tasks. Step 1 is master scheduling. Management establishes top-level milestone dates and the final completion target. This defines what should be done at a high level. Step 2 is phase scheduling, or pull planning. Instead of pushing a schedule down, the last planners work backward from those major milestones to define the exact handoffs required from preceding trades. Trade foremen use color-coded notes to negotiate with each other. They calculate their own durations and lock in collaborative commitments regarding when a space will be released to the next crew. Step 3 is look-ahead planning. The project superintendent generates a 6-week make-ready schedule based on the pull plan. This allows the team to identify distant constraints and clear them before the work begins. This establishes what can be done. Step 4 is weekly work planning. The 6-week look-ahead is filtered into concrete week-by-week commitments. Trade foremen generate a tactical plan of exactly what will be done in the coming days. By replacing top-down guessing with bottom-up collaborative promises, these 4 steps create a reliable flow of work across the job site. This drawing depicts the 5th and final component, Percent Plan Complete, or PPC. This is the feedback loop used to measure the accuracy of the team's promises. At the Friday huddle, the team scores the weekly work plan. PPC calculates the percentage of commitments completed. For example, if 10 tasks were promised and only 5 were finished, the score is 50%. The team then documents the exact root causes for every missed commitment, whether it was weather, manpower issues, or delayed design information. Tracking these root causes over time prevents repeated failures. If a 12-week trend shows that materials are consistently causing missed promises, the team can focus their energy on fixing the supply chain. Without the PPC feedback loop, a job site cannot self-correct. Objective measurement is the only way a lean team identifies the specific areas that need improvement. The Lean Builder methodology is an integrated operating system. Its components rely on each other to maintain the schedule. First, the site identifies downtime wastes. Second, it processes those issues through daily visual huddles. Finally, it secures execution through the last planner system. Field performance improves when we empower the last planners, make roadblocks visible, and measure our commitments with objective data. Thank you for watching Bodhi Unified Flow. For a complete guide to field implementation, consult The Lean Builder by Donarumo and Keyan Zandy.